Good afternoon, everyone. Today, I'm going to give presentation on memory hierarchy. This is snehith from CSE-H. So today, topic is memory hierarchy, and memory hierarchy is used in computers to explain about how memory is utilized and how computers they are sorted based on expensiveness and fastness and how much the storage capacity they have. To balance speed, cost, and capacity, computers use structured arrangement called memory hierarchy. And coming to the hierarchy levels, we have at the first place registers and then cache L1, L2 cache, RAM, main memory referred, and secondary storage. Coming to registers, registers are made up of a tiny group of flip flops which can store one bit of data at a time. So grouping many of those flip flops get a register. Registers are extremely fast. They are integrated internal inside the CPU. They have the smallest capacity, but they can match the electronic speed of CPU to give the information so that the performance of computer can be increased. Memory hierarchy is arrangement of storage of components in a computer way. That frequently used data stays is the fastest level. Less used data stays in slower on longer levels. The goal is to achieve CPU fastest access while keeping the total system cost at lowest possible cycle. So in the PPT, you can see CPU speed, memory access speed, and memory wall. CPUs have exponentially more speed. Memory access speeds have much more slow when it's considered with a random access memory, so it will indirectly impact on the performance of the computer. So to overcome that, the solution is memory hierarchy. It gaps the difference between the access speed. And in the next slide, you can see the principle and the cache arrangement. The cache has access to CPU as well as RAM. So in the main memory, we have all the programs which are running, and cache stores only few amount of memory which is currently needed by the CPU or demanded by the CPU. So the tiny bit of information which was needed for that particular time was taken by cache and implemented, and then it is deleted based on many principles, mostly used queue, which uses first in first out, or LRU, last recently used. And coming to the next slide, we have seen here like SSD, HDD, RAM, and cache. Here a real world example, we will see web browser performance. Register store the current instruction addresses and immediate data. Cache stores executed browser code and active DOM elements. L2 or L3 cache contains frequently used JavaScript libraries and CSS rules. And RAM stores entire web page content, image, and browser applications. SSD or HDD persistent storage for cached files, cookies, and browser data. On the first visit, data is loaded from storage, which is very slow. On the subsequent visits, data stored from cache levels, which is really fast. So the result will be 100 to 100,000 times faster than original load page time. So this is all about memory hierarchy. And thanks.